right, so let's go over these. So we have x squared plus 3x plus 2. So Lashla, what is this asking me to do?
Make the two parentheses thing.
Okay, right, so we have to break it up into two parts, right? So now, all right, are we actually changing the problem here? No, right? So when we're factoring, we're just rewriting it to be the same, to be an equivalent expression, but it's just written differently, right? So how do I actually factor this first expression? Someone on the left one, Alex.
Gotta see what multiplies into 2 and what adds into 3.
Okay. So what are two numbers that multiply to 2 that add to 3?
2 and 1.
Okay. So now that I have those two numbers, right, what would be my expression then?
It'll be parentheses x plus 2, parentheses x plus 1.
Good. So that's the first one. Dan, number 2.
Say, you want me to give an S or, oh, I did it wrong.
Okay.
Let me do it.
So do you know what your mistake was?
Yeah.
What was your mistake?
I had
making
why you
faces.
factored out the X. I think so,
Okay. So why can't I actually factor an x out of this?
because like,
Okay. That's actually a really good question. Why can't I factor an x out of this? Only an x. Kazir.
Because the 6 doesn't have an X.
Yeah, this 6 is missing an x. You have to have an x in all three terms to be able to factor an x out of this. So Amrose, when we actually factor this, what should this become?
I'm gonna try.
Okay, go for it.
So x. Oh no, plus x.
Good.
I'm gonna say plus 5. No.
oh, well,
Davion.
X minus 3
Good. Now Lashlar, why is this the correct expression?
First of all, I didn't even have that.
Okay. So this is why we're doing this. We're just reviewing, right? So Alex.
This is correct because if you multiply -3 and -2, you get +6. And if you add -3 plus -2, you get -5.
Good.
So,
Yeah.
you can't have x plus 1 and x minus 6.
What?
Okay. So Lashlar is asking. Can she use those
Oh,
two factors?
never mind.
No,
never
she
mind.
can't because it's
Okay, I already
multiplied
felt
from
the
the
conversation.
-6.
Chill out.
Well, when I was walking around, I saw someone else with this tip. So why can't you use this?
Oh, because 6 is right there, and you have to get +6.
Good. And what is -6 and 1 multiply to?
-2.
Good. Yeah. So they have to multiply to be +6, just like Lashlar said. Okay. So I see a couple pencils moving and making some changes. Okay, so now, if we're going over number 3, it says we're trying to find two numbers to multiply to get you -12, but then when you add them, you get -4, right? What are two numbers that work for that?
-6 and positive 2.
Good, so now we have those two numbers. What would be our new expression?
It will be x parentheses x minus 6 parentheses x plus 2.
Good, I agree. Yeah, John, but first, before you answer, what is different about number 4 compared to the other ones?
This 0x.
Good, this 0x term.
Okay. I got x plus 6 and x minus 6.
Good. I 100% agree. So now, I wrote it this way because I wanted you guys to see something. These are the types of problems that we're going to be focusing on today. And our homework is actually going to have some review problems like the ones we did up here. So I know we're a little bit shaky with those still. But the homework, we're going to have some extra opportunities to practice this. But these types of problems, we're going to be focusing on today. Now, have you ever seen a variable with a 0 in front of it?
No.
No.
Yes.
Guys, well, most times you're not gonna have it like that, right? So what we're actually gonna see is it gonna be written like this. These two expressions are actually the same thing. And so what we're actually dealing with today, this, and I want you to write this on your paper, is called difference of squares, right? So when you hear the word difference, Victor, what do you think of? Subtraction. I agree. And then when you have squares, the difference of squares is that they are two square terms, right? We have square number 1 because it's x squared, and then we also have 36, which is another square, right? So what's the square root of 6, Jen?
Wait, what?
What's the square root of 6?
Um,
Oh my god, I just gave it away. Square root of 36 is 6. Sorry, I was getting excited. So now if you had the difference of squares, all you need to know is what the square root of this last term is for the beginning problems. Right? You have to figure out what is the square root of this last term, and then you just rewrite it like this. As plus the square root minus the square root. Right? Just like Gianna said. But the reason for it is that they have to add up to 0 when you multiply and you add these two terms. Okay? So let's do one more. So right below, I want you guys to write this. So we have x squared minus 9. Okay, so Alex is writing it down. Jed's copying it down. Thank you, Ray.
X minus 9. It'll be
Right? So now, this is a difference of squares. Right? We have subtraction of 2 squares. So what's the square root of 9, Kazir?
3.
3. So what are my factors going to be when I rewrite this?
It's gonna be x plus 3 and x minus 2.
That's all we're doing. That is all we're focusing on. This is a special type of the problems that we were working on, what would that be? Tuesday before the snowstorm. Right? It's the same principle, just a special type of problem. Question.
So when it's positive 9, you put plus 3 plus 3?
Well, let's take a look at that. That's a great question. Does the difference of squares apply to x squared plus 9? So if we were to write this, Lashlar is asking if x plus 3 works. So what I want you to do on your paper is I want you to FOIL, right? FOIL this out and tell me, does this get you the same answer? Don't call it out. I want you to FOIL these two terms, because we're checking to see if they're the same. If you FOIL these two terms, they should get you back to this. So Kazir's FOILing it out. Maria's FOILing it out. In 20 seconds, we're going to go over it.
Bless you.
Victor's got his arrows drawn.
This is a very different equation.
I do my arrow to tell me what this is.
This is a very different equation, last round.
Okay. Show of hands. What did you get when you FOILed this out? Ari.
I got x squared.
Ain't that right,
So now, the question becomes, are these two equivalent?
No.
No, right? There's this 6x term that's here. So, does the difference of squares apply when we have x squared plus a square?
No.
No, it does not. Yes.
So what equation do you use for the plus? Are we not doing that today?
So now the question becomes, is this factorable? The way this is written, this is not factorable, based on the skills that we have. So at the very, very, very end of the unit, we're going to look at a formula that you can apply to any quadratic that you can use for this. But for right now, we're going piece by piece. And so today, because it's the difference of squares, not the sum of squares, we cannot apply this concept. Cool. Any other questions? Okay, so what I want you guys to do is I want you to look at this worksheet right here, where we have difference of squares. And I want to look at 1 and 2. Now, I also handed out, ever so graciously, a table of squares, right? Because some of us might not be like 100% proficient with our squares. And there's also some weird ones, like 17 squared, right? That's something that most of us don't have memorized. So I handed out a table that if you see a number that you don't know what the square root of it is, you can refer to this table as a guide to help you. Because I don't want you guys to miss out on the concept. I want you guys to be able to practice it. So I have this table here. So actually, before we go over an example one, I want you guys to look at this. So nice and easy, right? Over here, I have it written out as the square. So if you take 1 squared, you're going to get 1. 2 squared, you're going to get 4. Right? Hold on. I'm waiting for it. There you go. So over here then, we have the square root. So one's going from squaring, the other column is telling you the square root. So let's say we wanted to figure out what the square root of 16 is. We would look here, we would find the column, and we would go all the way down until we find square root of 16, and then it tells us that it's 4. So now, what I want you guys to do is, I want you to tell me what the square root of 361 is. So looking at the column,
19.
yeah, so you would just go down until you find 361, and you would know that it's 19. Okay, so that's the process that you would use this table for when you're actually finding the difference in squares. So now let's take a look at an example here. Alex, what do I have to do to solve the first one?
You gotta find the square root of 49.
Okay. Okay, so what is the square root of 49? 7. So then, if my square root of 49 is 7, Kayla, what do my two factors become?
A plus 7 and A minus 7.
Yeah, a plus 7, a minus 7. Okay, so now, what I want you guys to do is, I want you to circle 11 and 20 for right now. Or 11 and 12. 13, 15, and 17.
So we don't show 20.
Now, what's unique about these right here? All right. Yeah, there's a coefficient. What do we notice about those coefficients in those problems that I've circled? What do you also notice about them? All right. They will be factored, but we're not trying to factor them out. What do we notice about those numbers here? I heard a key word. They're squares, right? 2 times 2 is 4. 3 times 3 is 9. 3 times 3 is 9. 4 times 4 is 16. So the only thing that changes now is you take the square root of that and you put it in front of x. So let's take a look at this. If I wanted to factor this, what's the square root of 4, Dan? Oh, sorry. What's the square root of 4? 2. And what's the square root of 25? 5. So this is what your answer would be. 2x plus 5. 2x minus 5. All you do is you take the square root twice. Alright, so what I want you guys to do now is looking at those and using it as an example, I want you to work through the first point.
The first one? 20.
Out of your table. Okay, Kayla's worked through the first 20.
Can you move it, please?
Put it back up as an example. Sure.